Swayam Prabha. Digital India. Educated India.
Dear friends, in the last class we discussed about the decision making process in system engineering, and we saw a few methods of using graphical tools to make the decisions based on the probability and other aspects. We saw one example also. So today we will try to see a few more examples. So in last class we discussed about this problem of whether to have a function in SAC or in IIT. So depending on the weather condition, and if you know the probability of these conditions, how do you make a decision about having a function in a particular venue. That was a decision making process. Of course it was not a very complex decision making process, a simple decision making process where we use the probabilities as well as the known chances and use these to get a proper decision. We will see another example today which is slightly more complex than this. So this is basically a company is trying to build a plant for a particular product, and they have to make a decision whether to go for a fully automated plant or go for a conventional plant. And if they go for a conventional plant, then they have an option of upgrading this to a automated plant at a later stage depending on the market demand for the product. So here the company has to make the decision even before really getting the actual product or really getting some real data about the sales. So they need to depend on various factors like the probability of success of the product, and for 10-year period what will be the changes in the sales or how much revenue they will be able to make. So based on all this information they have to make a decision at this stage whether to go for a automated plant or a conventional plant. So the problem statement is given here. The company is trying to decide whether to build a conventional or automated plant to produce a new product with an expected life of 10 years. The decision must be based on the size of the market for the product. Simply look at the market and then decide whether to go for an automated plant or for a conventional plant. And they have some values or some approximation or estimations based about the sales. So the demand is expected to be any of the following three cases. So they have identified three cases the demand is going to change. The first one is the demand is very high during the first 2 years, and if found unsatisfactory by the users then it will be very low thereafter. So initial 2 years they will be getting very good sales, but then depending on the product, if the product is not satisfactory then the sales will go down. And the other possibility is that the demand will be high over the next 10 years. So they are expecting that the demand will be very high over the next 10 years. Or the third possibility is that the demand will be low over next 10 years. So these are the three possibilities, and again we need to find out what is the probability of these three events occurring, and based on this and the revenue they need to find out what should be the decision whether to go for an automated plant or a conventional plant, and the investment for these two, that is for the conventional or automated plant, will be different. So now we have to have some estimation of the demands, the probability of various demands. So we will identify what are these probabilities, and then based on this we will try to make a decision tree, and then using the decision tree we can arrive at a particular decision. So let me give you all the values of the probabilities of various sales scenarios. That is, we have three scenarios we identified. So we have this initially very high demand, and low after 2 years. So that was one case. There we have this probability of 15%, or we can put it in percentage. 15% is the possibility of this situation. The other one is it is initially low, the demand will be initially low and be high after that. So this is for there is no possibility of this is not identified, so that will be a 0 possibility for this one. Then initially high, so initially you have very high demand and this is sustained over the next 8 years. So this possibility is around 60%. Then we have this initially low and it continues to be low, and this is sustained, the low demand is continuing, that is another possibility, and this probability of this one is 25%. Now using these values we can actually identify few other scenarios and find out what will be the probability of those events happening. The chance that initial demand is very high, so we had condition this is initially high and this is also initially high and these two are initially low. So these are two conditions where we can have initially high demand. So this probability will be 60 plus 15, 75%, and then this initial demand high and it continues to be high, the probability is actually initially high and sustained is only 60%. So this will be 60 over 75, it will be 80%. So if initially it is high, the chances of it continuing will be around 80%. So here now we have to look at the income from these plants. Suppose we have a plant, what are the possible income from these plants under different situations. So if you have an automated plant, and it is giving high yield, high outputs, then the revenue will be around 10 million per year. So that is the expected revenue. These are all estimates, so we are yet to start the industry, so these are the estimated revenue. And you have an automated plant but the low yield, that means low sales, then the revenue will be only 100,000 per annum. We need these values to calculate the expected value of the different scenarios. And if you have a conventional plant, so we have two options, automated and conventional. So if you have a conventional plant and the high yield, high demand or high yield, then it will be 400,000, and if it is low it will be 300 per annum. And if you want to upgrade the conventional plant, or your conventional plant upgraded, to meet high demand, it will be 600,000. That means after 2 years if you change this to automated plant, and this 400 will become a 600 with high demand. And the same situation, low demand, upgrade it but the demand is low, then the revenue will be so these are the estimated revenues. And the construction cost, this is the revenue, and the construction cost, automated plant, will be $50 million, then this will be conventional, be 20, and if you want to automate after 2 years, that is conversion or upgrading of conventional plant, again it will be another 20 million. So these are the costs involved in setting up the plant. So if you have an automated plant, conventional plant, or conversion of the conventional plant to an automated plant. So these are the data available for decision making. So we have to make a decision whether to go for a automated plant or a conventional plant, and the options are that you can, if you start an automated plant, you can get a various sales, you can have a continuously high demand for the product, or you can have a high demand for initially and then low demand. So if you go for a conventional plant, then again you have a initially high demand which is sustained, and initially low demand it is sustained. So these are all the probabilities of having these kind of sales, and you can again identify the chance that initial demand is high is only 75%, but it continues to be high will be 80%. So these are the various possibilities of sales, and these are the revenues expected from these plants under various situations, that automated plant high yield, low yield, conventional plant high demand, low demand, similarly conventional plant upgraded, and these are the cost required for establishing the plant or conversion of the conventional plant to automated plant. Now based on this information we need to make a decision tree which will actually depict all these values and then tell us what are the chances, what are the decision we can make, and what will be the expected utility or the expected value of various decisions. So here, as you know that in decision trees we have a decision node. So the decision node is represented by a rectangle. So this is the decision node, and in this case we will be having two decisions. This is decision 1, whether to go for a automated plant or conventional plant. Then the second decision will be, if you have a conventional plant, whether to automate it or not, whether to upgrade it or not, that will be the second decision. So here in this decision we have two options, two chances, that is you have a chance node here and you have a chance node here. So this is automated plant. So this is the automated. So build an automated plant is one with an investment of 5 million, and then you have this conventional plant with an investment of 2 million. Here once you have this, we have three chances. Again we have these three chances like various sales, you have initially high demand and then it is sustained, or initially high demand which is reducing, or low demand throughout. So we can actually represent all these. Here you have one decision, one chance, this is another one, and then you will be having this situation. So this is basically high initial demand, it will be getting, then we have low thereafter, and here the low average demand. So this is the low demand, and here the probability is given as 0.6. So you can get here this initially high, sustained is 0.6. So this is the high initial and sustained is 0.6, and this is low demand, it is 0.25, and this is 0.15, initially high and then reduces low after 2 years. So it is initially high, low after 2 years, that is 15%, that is the probability 0.15 here. So this is initially high, then low. So these are the three chances here. We know the revenue what is going to be for these various situations. So we will write down this revenue also here. So here the revenue is 10 million for 10 years. So the plant life is assumed to be 10 years, and so 1 million per annum. we assume that the total revenue is 10 million. Now here the revenue is 2.8 million for 8 years. Yeah, so this is 2.8, the initially 1 million per year for 2 years, and so it is 2 plus 0.8, so 2.8 million for this first in 2 years, initially very high, so 2 million, and then it is very low, it will be 0.8 million. So 2.8 million is the revenue, and this is only 1 million is the revenue. So that is the output here. So this automated plant with an investment of 5 million, and you have the 3 possibilities here: high initial demand and it is continued with an output of 10 million, initially high but then it is reduced 2.8 million, and low demand 1 million. So these are the 3 possibilities over there. Now look at here, this conventional plant, you have high initial demand and low initial demand. So if you have high initial demand for the first 2 years, this is low. So when you have a high initial demand in the first 2 years, we will actually go for this possibility is 0.75 high initial demand, and then in that case we will take a decision whether to go for an automated plant or upgrade it or not. So this again a decision node, this is the decision 2. So you have another decision to be made here, and again you will be having all the 3 possibilities. So you automate the investment, so this is chance node, automate with an investment of 2 million, or you can go for the so this is the other one, go for the conventional one, no change, this is no change. So this decision node will take a decision whether to automate the plant or not. So one option is automate with a 2 million investment, other one is no change, and again you will be getting, this is a high initial high. So after initial high you will be having 2 options, one is sustained, other one is low. So this is a sustained high demand, continuous high demand, probability is 0.8 here, and this low demand it is 0.2. This will be 5.6 million revenue, and this will be 1.2 million, and similarly here also you will be having high and low, again the possibility is 0.8 and 0.2 high and low, but here the revenue will be 4 and 3.2. Okay. So that is about this decision, and here again you will be having the same situation, this will be going as this output. So here you will be having a 3 million revenue, and this is a low initial demand, so the probability is 0.25. So these are the decision nodes, 2 decision nodes, and these are the chance nodes. So as you can see here, so we have the initial decision to be made whether to go for an automated plant or a conventional plant. So for automated plant the investment is 5 million and conventional it is 2 million, and when we go for an automated plant the possibilities of sales are here 3 possibilities: high initial demand which is sustained, initially high but it is low thereafter after 2 years, and low demand throughout. The probabilities are 0.6, 0.15 and 0.25. Again the revenue is calculated as 10 million for this situation, 2.8 million for this, and 1 million for this. So that is the first situation when you have an automated plant. But when you have a conventional plant, if there is a very high demand for the first 2 years, so the company can decide in such a way that they go for a conventional plant initially, and depending on the demand they will try to change it to an automated plant. So here the conventional plant 2 million investment, and the demand very high is 0.75 for the first 2 years. If that is the case, then actually they can decide whether to go for an automated plant or to upgrade it to an automated plant or not. So these are the two chances, upgrade or not. The upgrade is the investment is 2 million and this here the investment is not there, no change, and again the high demand is continuing, it will be getting 5.6 million. If it is not continuing, it will be getting only 1.2 million. So that is the revenue. So in this case the no change, then again if high demand 4 million, otherwise 3.2 million, and if this is not changed, then the revenue will be 3 million. So these are the data available to make a decision. Now as we discussed previously, we need to find out what will be the expected value of these decisions. So you have a automated plan decision or a conventional plan decision, we need to look at what is the expected value of these decisions. So we have the investment and we have these probabilities. So looking at these probability and the other revenue values, we will find out what will be the expected value of these two decisions first. So as you know, the expected value is basically the probability multiplied by the utility of the event happening as well as the event not happening. You add them together and you will be getting the expected value of the decision. To find out the expected value of the first decision, we need to find out this expected value of this decision and expected value of this decision. So the expected value of the automated plans, if you go for an automated plan, expected value can be obtained as 10 million into 0.6, that is the revenue 10 million, 0.6 plus 2.8 million into 0.15 plus 5.6 million multiplied by 0.25 minus 5 million. So this 5 is the investment and these are the revenues, these are all the revenues for the three cases and its probabilities, and that will be equal to so this will be the expected value of the first decision. Similarly for the conventional plant, the expected value will be 3.04 plus 0.8 because we have a 2 years revenue plus the other revenue. First 2 years you will be having this revenue and then other revenue. So 3.4 plus 0.8 multiplied by 0.75 plus 3 to 0.25 minus 2 million. So this will be the expected value of the conventional plant and it will be given as 60,300. So these are the expected values of these two decisions, whether you go for an automated plant or a conventional plant. This actually tells you what is the expected value of these two decisions, and from there we can see that this has got a high expected value of the decision, therefore can go for the automated plant. That is the first decision, whether to go for an automated plant or a conventional plant. But in case the company decides to go for the conventional plant, then again the decision has to be taken whether to go for the upgrading or not. So that also again to be calculated. So we need to see what is the choice here, whether upgrading or not upgrading, and how do we take a decision at this point. So here again we have to take a decision whether to upgrade the plant or not. So this is done by looking at the high average demand, the possibility of 0.8 and this is 0.2, and here you have this again 0.8 and 0.2. So we can actually get the expected value here as expected value of decision 1 whether to automate or not, that is upgrading. So this is upgrading, expected value will be given as 3.84 it will be 3.84 plus 0.8, it will be 3.92 minus the 2 investment 2 million. So it will be 1920, that will be the expected value of the first decision to automate it after 2 years. and if it is not upgrading, then the expected value is 3040. So this will be the value of the, of course you will have in millions, 3.04 million. So therefore you can see that this expected value is very high in this case. So here the expected value is only 1.92, here it is 3.04. So if the company decide to go for a conventional plant initially and then whether to go for a automatic upgrading or not, it shows that if not upgrading, then it is the expected value of the conventional plant itself will be very high compared to the expected value of the upgraded plant. So therefore the company can decide not to upgrade even after 2 years, because the expected value of a non upgraded plant will be much higher than the upgraded plant. So using these expected values, basically we look at the various probabilities of sales, and then we find out the revenue for estimated revenue, and we calculate the expected value of various options, and based on these expected values we can take a decision whether to go for a particular type of plant or not. So that is the advantage of using decision trees, and this is how we make a decision based on the available data. So all these data whatever we assume here, they are all estimated values, they are not the real values. So based on the estimated values we can find out what will be the expected value of this particular decision, and based on that proper decision can be arrived at. So this is how we use the decision trees to make a decision in the system design. So that was about the decision trees. The another tool we normally use for decision making is influence diagram. So this influence diagram also basically gives similar information, or it can be used for same purpose of making decisions, but they actually give better information, basically the dependability of the decision on what is the kind of dependency existing, and what kind of relationships are there, how it is related to a particular decision, or how much it can influence the decision. So that is shown in the influence diagram. As you can see here, it is a graph theoretic representation of a decision. So it is a more of a graphical representation, and there are 4 nodes: a decision node, a chance node, a value node, and a deterministic node. So these are the 4 nodes normally used in influence diagrams, and there are directed arcs between the nodes. So these directed arcs basically shows the kind of relationship, so which one is depending on the other one, that is shown using the directed arcs. And then a marginal or conditional probability distribution defined at each chance node, value node, and deterministic node. So we can actually define some kind of probability for these nodes, and that can actually be incorporated into the influence diagram, which will tell you how much dependency is there between different nodes. And here the decision nodes are square boxes, chance nodes are oval, and value nodes are square with rounded corners. So this is how we actually represent the influence diagram using these nodes. I will take few simple examples and explain how do we use the influence diagram to represent the dependency of various decisions, and how the interrelationship and how the directed arcs actually represent the relationship in the influence diagram. So as I mentioned, it has got a node, a square box as a node, a decision node. So this is the decision node, and you can actually have discrete number of events attached to the decision node. You can have a discrete number of decisions coming out of the decision nodes, or discrete number of states. We can say the decision node can have discrete number of states. Then we have the chance node, it is represented using an oval. This is the chance node, and again this will be a random, discrete random variable. You can actually find out what the number of chances are existing. And then we have this value nodes, they are represented as round triangles with rounded corners. or you can actually represent it as diamonds also. These are the value nodes. Then we have the arc which actually determines the dependency. So arc is nothing but an arc which actually represents the dependency between these nodes. So these are the basic construction elements for influence diagram. So these are the influence diagram elements. Let us take a very simple example to show how do we use the influence diagram to represent a particular decision making scenario. So of course this will not give you a decision directly, but we can actually represent the interrelationship between various nodes and chances and the decision making process, how actually they are related and what kind of influence a particular event makes on the decision. Let us take a very simple example of a vacation planning. So someone is planning to have a vacation, basically a short duration vacation. They are planning to go to a outstation, basically a place where the tourist location, but there are so many factors which actually affects this decision. So here we can represent the decision node as vacation planning. And then there is a value node which is represented by a round triangle. So the value node is what is actually the outcome of that particular decision. So we have to plan a vacation and the value is basically what actually we achieve through that particular decision. So here basically the satisfaction of going for a nice vacation is the value. So that is the value here, but then we will consider one scenario or the one chance that the weather condition which actually influences the vacation planning. So that is one chance. This is the weather condition. So the weather condition can actually influence the satisfaction and your vacation planning. So that is why we can actually show in the influence diagram weather condition, and then weather condition actually can be obtained from another possibility that you can actually have the weather prediction data. So weather prediction may be available which can actually be used for decision making. So that is the weather prediction. So these are the two chance nodes and this is the value node, this is the decision node. Now we can see that there are two functional arcs, which actually one is this, the satisfaction, and this is the satisfaction. Okay, so the vacation planning can actually, the satisfaction, it is a functional arc to the satisfaction because this actually leads to satisfaction, and this weather condition also actually influences the value here, the satisfaction. That is why you have two functional arcs here. That the functional arcs. So of course we can actually add to this the probability distribution, then it becomes easy for the decision maker to find out, to make a decision, but we are not going to that part. We are just showing how to represent that decision making process using a influence diagram. So here, and then we have an information arc here. So this is an information arc. Okay, you can see that this weather information is used for the vacation planning. That is why there is an information arc which actually influences the decision of vacation. So depending on the weather prediction, the vacation planning will be done and then lead to the satisfaction depending on the actual weather condition. So this is the predicted information, but the satisfaction actually depends on the weather condition. It has no relation to the weather predicted, and similarly vacation planning has nothing to do with the weather condition, because we do not know the weather condition. So there is no influence on the weather condition on the vacation planning. So this actually shows that what actually is going to influence the vacation planning, it is not the weather condition which is going to influence, it is the weather prediction which is going to influence the vacation planning. So that is why we are having an information arc over here, and the satisfaction or the value of the vacation basically depends on the weather condition. It has nothing to do with the predicted weather, and what is the weather condition that actually decides the satisfaction level of the person who actually plans for the vacation. So this kind of simple diagrams can be used to find out the dependency of these decisions. As you can see, the vacation planning has nothing to do with the actual weather condition, that is why there is no arcs over here, which shows that there is no relationship between the actual weather condition and the vacation planning. So that was a simple example. I can show you another example where the company wants to make a decision on buy or build. So we actually developed a decision tree for this particular case. In the last class we discussed how do you actually decide or make a decision tree for this buy build decision, whether a company wants to buy a particular product or they want to make the product themselves. So that is a decision they need to make, which can actually be represented using the decision tree, and then decision tree can actually have all the values, the probabilities as well as the cost and other factors. In decision tree of course we can actually add those parameters also, but for the time being we will be just showing how do we actually make the decision tree for this particular situation. So here the decision node is basically buy versus build. So that is the decision node here, and there are two factors which actually affects the value is basically the value it gives to the company. So that is the value node here, but actually the value it brings to the company is the output or the value node here, something like satisfaction. And the two factors or the two chances are that it may actually lead to build cost and the build schedule. So build cost and build schedule, these are the two chances, build cost and build schedule. So these are the two chance nodes, and then we can represent this as actually influences this, and this actually leads to the value. So these are the two chance nodes, this is the decision node and this is the value node. So what actually determines the value is basically the build cost or the build schedule, and the decision has not direct influence on the value here, because depending on the build cost or the build schedule, if the depending on the probability of this increasing or decreasing, that actually leads to the value of that particular decision. Now if you actually add the probability of the cost increasing or the probability of the schedule delay, accordingly we can actually calculate the value and then make a decision based on that, which one actually gives you the highest value, so that decision can be taken. So we can actually choose a particular decision based on that. So this is how we use the influence diagram to represent the buy build decision. Again this is a very simple example, but we can actually go for complex cases and then see how do we actually develop the influence diagram for such cases. I will just show you one particular case. This is basically the requirements allocation decision for elevator system, and we studied about the elevator system, and we know that there are many factors to be considered when we design the elevator, and there are many requirements for the elevator, and the requirements allocation actually depends on the particular decision, whether the cost is important or the performance is important, or what actually the overall objective of the design. So in this case what is shown in the diagram, you can see here that the designer basically looking for the high tech control or a high tech power, but of course the low risk one. So that is the decision to be made. So go for a high tech control or a high tech power. So you can see here that the main decision box or this box has got three parameters: high tech control or high tech power, and then the three chances, any one of these we take any decision over here, that actually going to affect the cost, performance and availability. So these are the three chance nodes we have here. So this is a decision node, this is the chance node, cost, performance and availability, and of course we have this value of the fundamental objective to be met. So fundamental objective is basically the design objective or the purpose to which the design is being made or the elevator is being made. So that fundamental objective is to be met, whether you go for a high tech control or high tech power, we need to meet the fundamental objective of the system design. And then we have the other chance like power technology and controller technology. What is the availability of the power technology and what is the availability of this controller technology? These are the two chances you have. So we have this cost, performance and availability, and then power technology and controller technology as the chance nodes. And based on this actually we need to take a decision. What actually influences this particular decision is the cost requirement. So you can see here again there is a decision box here, cost requirement, performance requirement and availability requirement. So any chance or any decision on this cost is actually a decision on the cost requirement. So we have the cost requirement, so the decision has to be taken based on the cost requirement, performance requirement and availability requirement. So these are again becoming the decision nodes. Again basically this availability and cost, they are actually again depending on this chance of power technology. Availability of the power technology and the cost of the power technology also influences the decision to be taken here. So the influence of these chances on this decision is represented by these arrows here. Similarly the control technology, the availability, performance and cost, all these three are actually influenced by the controller technology. So that also is shown as arrows over here. So this actually shows that the performance, cost and availability all depends on the controller technology available, and then we have to take a decision based on the cost requirements, performance requirements and availability requirements. So this way we can actually represent all the parameters involved in the design, basically looking at the objectives and the requirements and the chance nodes existing. So whether you want to go for a high cost one or a low cost one, and what kind of performance you are looking for and what kind of availability is there for the technology or the controller technology or the power technology. So this kind of diagrams basically shows you the influence of the chances on the decision making, how much influence that has got in the decision making process. So those parameters can be easily represented using the influence diagrams. So that is the importance of using influence diagram in analyzing the decision making process. Any decision making process, as we know, that the purpose is to basically avoid the risk involved in decision making. So to minimize the risk involved in decision making, and many people or many designers actually follow different ways of avoiding this risk. So let us see briefly what kind of risk management techniques are being employed by the designers in order to reduce the risk in taking any particular decision. So as you know, the risk is actually the combination of the probability of an event occurring and the significance of the consequences of that event occurring. So if you have a probability of a particular event and then you have some significance of the outcome of that event. So this actually the risk is basically a combination of both these two. So you can have a probability of something happening, but the influence of that is very minimal in your design or in your that particular system behavior, then the risk is less. Even if that is a high possibility of that event happening, if the influence is or the outcome is not so significant, you can actually say that the risk is very low. So it is basically a combination of the probability of event happening as well as the influence of that event on the system performance. So to deal with the risk, we have the many methods. The activity of managing the risk through various processes are known as the risk management strategies. So we have different strategies like avoidance, risk transference, risk management and risk analysis. Basically risk avoidance is how do you actually avoid a particular risk, or you just go for a low risk alternative, that is you are avoiding the high risk thing and taking for a low risk or going for alternatives. The other one is basically the risk transference, basically the option that transfer the risk to others. Basically something like you, when you drive a car, you have a vehicle insurance, basically you do not want to take the risk yourself, so you are actually transferring the risk to a insurance company. So that is the risk transference, you manage your risk with to, or you transfer it to someone else. And then is the risk management, basically the use of fallback options in case of riskier option fails. So you have more options so that if something fails you will have another option. And next one is the risk analysis, basically it addresses the risk explicitly when decisions are made in uncertain situations. So risk analysis is basically to find out the possibility of that risk and its influence and then make a decision based on that. So analyze the risk in a detailed way and get the outputs, that is a risk analysis. And there are many ways for doing the risk analysis. Again we will have another lecture on this part, the risk analysis and how do you avoid the risk. This I just want to tell you, when you take the decision, the basic idea is to reduce the risk. So that is why I just introduced this topic to you. The more detailed discussion on this risk will be done at a later stage. To summarize whatever we discussed in the last 2 lectures on how do you make a decision, we found that decision making is a process where actually a lot of uncertainties are there. So we need to reduce, or we need to identify these uncertainties in the decision and try to find out what kind of, or how do we actually quantify these conflicting criteria in decision making. So that is one important part. How do we actually identify and quantify the conflicting criteria in decision making, and there are various tools for doing that. We saw few tools like influence diagram, decision trees and other methods where we actually model the decision scenario and try to analyze the expected values of various decisions, and based on that we will take a decision for appropriate for that particular scenario based on whatever the information is available. Your decision, final outcome of the decision, the actual impact of the decision will be known only after when you really make that implement that decision, but even before that you need to have some kind of an idea what will be the influence. So that is why we do the analysis and try to find out the impact of various decision, and then based on that we take a decision. So that is basically the decision making under uncertainty. So with that I conclude today's lecture. So till we meet again, goodbye to all of you.